Hello friends, my name is Pratik Patel and I am a student of Texas A&M University Kingsville and I am studying in computer science and here I am going to present a topic called a few useful things to know about machine learning. Here we are going to start. As you can see, my advisor is Dr. Young Lee. First thing first, what is machine learning? Machine learning is the most popular and fast evolving technique of artificial intelligence that provides ability to computer programs to learn themselves without being explicitly programmed. Applications of machine learning. Data mining problems like mistakes of analysis and false relationships establishment can be solved using machine learning. Machine learning can often be successfully applied to those problems, improving the efficiency of systems and the designs of machines. The first topic is in- intuition fails in high dimensions. After overfitting, the biggest problem in machine learning is the curse of dimensionality. Many algorithms that work fine in low dimensions become intractable when the input is high dimensional. Generalizing correctly becomes exponentially harder as the dimensionality is number of features of the examples grows because a fixed size training set covers a dwelling fraction of input space. The second mm, topic is intuition fails in high dimensions. Building a classifier in two or three dimensions is easy. We can find a reasonable frontier between examples of different classes just by visual inspection. But in high dimensions, it's hard to understand what is happening. This is turn makes it difficult to design a good classifier. One might think that gathering more features never hurts, since at worst they provide no new information about the class. Their benefits may outweigh by the curse of dimensionality. The second topic is theoretical guarantees are not what they seem. What this means is in machine learning papers are full of theoretical guarantees. The most common type is a bound on the number of examples needed to ensure good generalization. What should you make of these guarantees? First of all, it's remarkable that they are even possible. Induction is traditionally constructed with deduction. In deduction, you can guarantee that the conclusions are correct. In induction, all bets are off. The topic is continue. One of the major developments of recent decades has been the realization that, in fact, we can have guarantees on the results of induction, particularly if we are willing to settle for probabilistic guarantees. For instance, it does not say that if your learner returned a hypothesis consistent with a particular training set, then this hypothesis probably generalizes well. And the third topic is feature engineering is the key. Yeah. Feature engineering means at the end of the day, some machine learning projects succeed and some fail. What makes the difference? Easily, the most important factor is the features used. If you have many independent features that each correlate well with the class, learning is easy. On the other hand, If the class is a very complex function of the features, you may not be able to learn it. Often, the raw data is not in a form that is amenable to learning, but you can construct features from it that are. This is typically where most of the effort in a machine learning project goes. Suppose you have constructed the best set of features you can, but the classifiers you are getting are still not accurate enough. What can you do now? There are two main choices: design a better learning algorithm or gather more data. The quickest path to success is often to just get more data. A dumb algorithm with lots and lots of data beats a clever one with modest amounts of it. Yeah, as we see, more data beats a clever algorithm. So the more data is more helpful in learning. This does bring up another problem. However, scalability. In most of computer science, the two main limited resources are time and memory. In machine learning, there is a third one. It is training data. Enormous mountains of data are available, but there is not enough time to process it, so it goes unused. This leads to a paradox. Even though in principle more data means that more complex classifiers can be learned, in practice simpler classifiers wind up being used because complex ones take too long to learn. Remember, learn many models, not just one. In the early days of machine learning, everyone had their favorite learner. Together, most effort went into trying many variations of it and selecting the best one. Then, systematic empirical comparisons showed that the best learner varies from application to application, and systems containing many different learners started to appear. Effort now went into trying many variations of many learners and still selecting just the best one. But then researchers noticed that if instead of selecting the best variation found, we combine many variations, the results are better, often much better, and at little extra effort for the user. Simplicity does not imply accuracy. Entities should not be multiplied beyond necessity. In machine learning, this is often taken to mean that given two classifiers with the same training error, the simpler of the two will likely have the lowest test error. It means no free lunch. Theorems imply it cannot be true. The generalization error of a boosted ensemble continues to improve by adding classifiers even after the training error has reached zero. And the last topic is representable does not imply learnable. Every function can be represented or approximated arbitrarily closely. Using this representation, because a function can be represented, does not mean it can be learned. Example, standard decision tree learners cannot learn trees with more leaves than there are training examples. In continuous spaces, representing even simple function using a fixed set of primitives often requires an infinite number of components. And thank you, friends. Here I finished my presentation. I finished the few important things about the machine learning. I hope you enjoyed this presentation. Thank you. Thank you so much.